So what about Pluto? We didn't include it in the list of the major planets, so let's learn something about it and maybe a little bit about why it is no longer considered a major planet. Clyde Tombaugh, who was then 24 years old, discovered it using something called a blink comparator of photographs using a 13-inch telescope. Here are the two pictures that he used when he discovered it. These were taken on January 23rd, 1930 and January 29th, 1930, 6 days later. And it's not even easy to see the little white arrows that are on here pointing out Pluto. But inside there you can see a little white arrow pointing to a faint dot. And 6 days later, that little faint dot had moved to that position. That was the tip-off that it was part of our solar system. It was named by an 11-year-old English schoolgirl whose grandfather had been a librarian, and he happened to send the name in for her. The Disney dog, Mickey Mouse's dog, came after the naming of Tombaugh's discovery. There was a good deal of press coverage of the discovery, and Walt Disney may have chosen the name of Mickey Mouse's dog because of that, but we don't know for sure. Disney's chief animator at the time could not confirm why he happened to choose that name. The search for a ninth planet was an attempt to explain some behavior in Uranus's orbit that could not be explained by the gravitational effects of other known planets, including Neptune. And when Pluto was first discovered, astronomers calculated somehow that its mass was about that of Earth. Later, it was recalculated to be about that of Mars. Only after the discovery of its moon Charon could the mass be more precisely determined. And we now know that its mass is only about 1/25th that of Mercury. One thing that shows a distinct improvement is the quality of pictures of Pluto, although it took a while. Here are some pictures of Pluto taken with the Hubble Space Telescope that were the best pictures ever taken of Pluto prior to 2015. These are a great example of trying to push a telescope beyond its resolving power. At the distance Pluto was at that time, the resolution or the resolving power of the Hubble Space Telescope would have been about half the diameter of Pluto, and so it couldn't really resolve anything less than half of that. All you see are a bunch of blurry, kind of light and dark patches on the surface of Pluto. Let's see how Pluto's size compares with that of other solar system objects. You may not have heard of Sedna or Quaoar before, but they're objects out beyond the orbit of Neptune. Objects that far out began being discovered in 1930 with Pluto, then another in 1992. Then when the Hubble Space Telescope began posting its pictures online, more and more objects were discovered out there. I remember reading a newspaper article when the 100th object beyond Neptune was discovered by a junior high class that had downloaded the pictures of that part of space and happened to figure out this thing that moved out there, probably doing something like what Clyde Tombaugh did with a blink comparator. We'll learn more about these objects later. You can see here, though, that Pluto is smaller than Earth's moon and only about 1/6 as massive. Pluto's density is less than half of that of Earth's moon, which is why Pluto isn't that different in size with our moon, but it is much different mass-wise. This is showing the size of solar system objects from Earth on down. Even Mercury is smaller than two moons. Ganymede and Titan are both larger than Mercury. And then there are 5 more moons that fit in size-wise between Mercury and Pluto. This comparison chart was made before another object was discovered out there. These are the largest known Kuiper Belt objects, which is a term to describe the things that are out beyond Neptune. We'll learn about that in another video. But here are the largest objects in it. Eris is at the upper left. It's actually a tiny bit smaller than Pluto, something like 50 kilometers in diameter smaller out of about 2,700. So not that much smaller than Pluto, but Eris is actually more massive than Pluto. Eris would have been in that previous picture if it would have been discovered earlier, but its discovery was announced in 2005. In 2006, the International Astronomical Union defined a planet. They had never done that before, and with all the new discoveries that were being made in the outer solar system, they thought the time had come. So the first condition is that the object has to be in orbit around the sun and not orbiting another planet. So the moons of the planets wouldn't count as planets. The object has to be massive enough to be rounded by its own gravity. If you want to see things that aren't, look at some pictures of asteroids to see those things. We will look at some of those in a later video. Pluto met the first two criterion, but it doesn't meet the last one. It must have cleared the neighborhood around its orbit. Now, that's a vague definition. There's an entire article on Wikipedia devoted to that. Cleared the neighborhood means that the object is gravitationally dominant, so that there are no other objects of comparable size other than its natural satellites or objects otherwise under its gravitational influence. And this is where Pluto falls short. There are objects of comparable size to Pluto in its orbit, and in fact, Pluto accounts for only about 7% of the mass of the objects near its orbit. By comparison, Earth accounts for more than 99% of the mass near its orbit. Not all astronomers have accepted these conditions. There's a fair amount of controversy. Different fields of planetary astronomy disagree with this, and so even though a large majority of the astronomers at the 2006 meeting did approve the resolution, they're still griping about it, and the definition may be altered more later. But if it is altered, there are going to be a lot more planets, things considered planets in the solar system. I don't have a problem with calling Pluto a minor planet or anything like that, but there were lots of articles and cartoons in the paper at the time. This one may not mean anything to you anymore, but Paris Hilton was a celebrity known for not much, but being a celebrity. But she recorded a CD that was not particularly stellar, I guess. Well, let's learn a little bit about the New Horizons spacecraft. It was launched to visit Pluto, and the speed shortly after launch was 16.3 kilometers per second. The escape speed from Earth is just a little over 11 kilometers per second, and so it was going well faster than that. It was the fastest man-made object ever launched from Earth. Some other spacecraft have reached higher speeds after they were launched because of gravitational interactions with whatever they were studying, like the Parker Solar Probe is going much faster than the New Horizons spacecraft ever has. But when it was launched, that New Horizons spacecraft was on the fastest rocket. When it was launched, also, Pluto was still a planet. The spacecraft had an encounter with Jupiter just 13 months after launch, which is really quick. It got a gravitational boost that sent it out to Pluto, and it had its flyby of Pluto on July 14th, 2015. Only 13 months to get to Jupiter. It got a gravitational kick from Jupiter that sped it up and sent it out faster to the outer solar system, but it took more than 8 more years, about 8.5 years, before it got all the way out to Pluto. The closest approach above Pluto was just about 1 Earth diameter above the surface of Pluto. 12,500 kilometers is roughly the diameter of the Earth. Because of the very large distance from New Horizons to Earth, the transmission speed for data was only 1 to 2 kilobits per second, which is not very much. Usually when you're hearing about transmission rates, you're hearing kilobytes at least, or gigabytes per second, or something like that, or megabytes. But kilobits per second is not very much. If you're a computer fan, you may be kind of amazed at just how slow that was. And there were 6.25 gigabytes of data that had to be sent back to Earth. That's why from July 14th, 2015 until October 25th, 2016 was how long it took to send all that data back to Earth. Then they retargeted the mission. It had flown by Pluto at a pretty good clip. They sent it on to the Kuiper Belt object Arikoth, and we'll see pictures of that in another video. And it got to it on January 1st, 2019. So a few more years on its path. This is the picture that this opened with. Nice picture of Pluto. It looks a bit sharper than the Hubble space pictures do, but again, it was only 12,700 kilometers away when it took this. The Hubble Space Telescope had to shoot the pictures of Pluto from 4.5 billion kilometers away. This is a picture of Pluto and its largest moon, which is pronounced either Charon, Charon, or Charon. And the people at NASA and the New Horizons mission have been pronouncing it Charon, so we may as well go with the flow on that one. This is a detailed look at the surface of Pluto. Lots of fine detail that you can see from these pictures that were taken. Here's some more amazing detail. The tiny looking pits in the upper left-hand part of this picture are from frozen nitrogen sublimating, more or less evaporating directly from the solid state to the gaseous state. This picture shows distributions of different types of ice on the surface of Pluto. CH4 is methane, the N2 is nitrogen, molecular nitrogen that's frozen onto the surface. CO is carbon monoxide, and H2O you probably know about. It's just frozen water ice. This is a close-up picture of Charon in somewhat false color to emphasize features. The reddish material at the top of the picture is from methane gas that escapes Pluto and then freezes onto Charon, and ultraviolet light from the sun transforms the methane, which is CH4, it's considered a hydrocarbon, and it converts it into heavier hydrocarbons and eventually into reddish organic molecules that are called tholins. And we see these in some of the other cold places in the solar system as well. This is New Horizon bidding goodbye to Pluto, looking back to see this silhouette of the dwarf planet's atmosphere. Pluto's atmosphere consists of nitrogen, the molecular nitrogen, N2, CH4, methane, and carbon monoxide. The pressure at the surface is 1,000,000 to 100,000 times less than Earth's atmospheric pressure, so that makes it a pretty good vacuum actually. Still, it has an atmosphere, and it's divided into about 20 haze layers, which are probably difficult to see in this, but it actually is kind of stratified into these layers. So, just a few Pluto facts. Pluto and Charon have the closest size pairing of any planet and moon in the solar system. Some astronomers call it a double dwarf system. The barycenter, which is the point that they both orbit, both Pluto and Charon, is outside of Pluto, about 960 kilometers above its surface. And the four smaller moons orbit the barycenter of Pluto and Charon. So Pluto and Charon each orbit that separately. They're tidally locked. They keep the same face toward each other all the time. Pluto spends about 20 years of each 248-year orbit closer to the Sun than Neptune. It has a more tilted orbit than any of the major planets, though, and when it is closest to the Sun, it is highest above the orbital plane of Neptune, so the two will never collide. And Pluto has a 2 to 3 orbital resonance with Neptune. That means that for every 2 orbits that Pluto completes, Neptune will complete 3. Or you can think of every time Pluto completes 1 orbit, Neptune will complete 1.5 orbits. I can't remember the exact numbers, but right now when Pluto is at perihelion, at its closest point to the Sun, Neptune is behind it by, I think, 50 degrees or something like that. And the next time Pluto completes an orbit, so it's at perihelion again, Neptune will be ahead of it at that point by, whatever, 130 degrees, I think, something like that. The two, Pluto and Neptune, are never closer to each other than about 17 astronomical units, which is quite a ways. An astronomical unit is 93 million miles, or 150 million kilometers, and 17 of them is multiplying those numbers together, so it's quite a distance apart. I hope you have some understanding of why Pluto may have been kicked out of the Planet Club. In a following video, we're going to learn about objects that Pluto has an awful lot in common with. These are the objects out in the Kuiper Belt. And you'll see that it doesn't need to be lonely. It's got plenty of company.